Good morning, everybody. I'm welcoming all of the participants to the second day of the AICTE ISTE sponsored refresher program on blockchain technologies and application. Our speaker for the day 2 session 1 is Dr. Sudeep Tanwar. I'm welcoming him to start the session. Sir, over to you.
Yeah, thank you very much. Thank you very much once again. So let me first share my screen.
Yes, sir. We are grateful to you, sir.
Yeah, let me just first share my screen. Just a minute. Let me open the PPTs and then let me share my screen.
Recording in progress.
I believe that my screen is visible to all of you.
Yes, it is visible.
Perfect. So let me just make it as a full screen and then we will start. So once again, good morning to all of you. And I believe that my voice is audible to all of you. There is no problem at all. And my skin is also visible to all of you. There is no problem at all.
Yes, sir. You are audible and your screen is visible too.
Perfect, perfect. Thank you very much for the confirmation. So once again, very good morning to all of you. And if you remember in the yesterday's first session, we have discussed about the fundamentals of blockchain, and we have already taken two implementations related to the blockchain. With there we have implemented the dummy blockchain, and we have already discussed about the internals of blockchain, that what is there, what is the architecture of blockchain. So now in this particular session, that is my session 2, we will be discussing about the consensus mechanism. So what is the role of this consensus mechanisms in developing the smart applications or any decentralized applications? Because as far as these consensus protocols are going to concern, there are wide variety of consensus protocols are available. Okay, so now the selection of consensus protocols are dependent on the type of blockchain that you are going to use, because in the previous session we have discussed that blockchain can be divided into three categories. The first one is the private blockchain, which we can call it as a permission blockchain. Then comes to the public blockchain, which we can also call it as a permissionless blockchain. And the third category we have discussed, that is the consortium or federated blockchain. Okay, so now coming to the consensus protocol in this particular session, we are going to discuss about the consensus protocol that are to be applicable in the permissionless environment. That means whatever consensus protocol we are going to discuss in the next 1.5 hours, all these consensus protocols are primarily used for the public environment, public kind of network, where anyone can join the network at any instant of time. Okay, so now moving further, before starting the technical discussion, let me tell you that what is the meaning of this consensus protocol. What is the meaning of this consensus protocol? So I will tell you in a very simple way. Forget about what is mentioned in this PPT. I will take a very simple example. So let's say in any family, there are 4 members, okay? And these 4 members have to take the decision that where they have to go for today dinner, okay? So you say that we need to go to McD. Your sister say we need to go to Pizza Hut. Your mother say we need to go to North Indian restaurant, and your father say we need to go to the Gujarati restaurant. So in a single family, having 4 members, and they have to take a decision that where they want to go for today dinner, all these 4 members are having all kind of different opinion. So now in this particular scenario, it is very difficult to reach to a common consensus. What is the meaning of this? To reach to a common consensus, that means it is very difficult that how they are come up with a kind of a common agreement or a kind of a common judgment that which restaurant is final, and that too it is applicable to all, or all parties are part of this. Okay, so in this particular scenario where in our defined applications we are having multiple stakeholders, okay, then reaching to a common agreement is sometimes a very tricky problem and very challenging. Okay, so in this particular scenario where in any of the applications we are having more than one decision maker, then for that particular case we need the consensus protocol. So what is the general meaning of consensus? We will discuss it. Consensus means reaching to a common agreement or a common judgment based upon the mutual consensus. Okay, so consensus means the agreement between the multiple parties. So let's say my agreement between the multiple parties, we can call it as a consensus. So in any of the network based application or any of the IoT based application, if we are having only one decision maker in our system, then there is no requirement to have the consensus. Why? Because in a normal Indian family, let's say if we say that no, whatever is the decision taken by the father, because he is the head of our family, so that decision is the final decision. So based upon that particular case, we can say that it is going to, there is no requirement of consensus. The consensus mechanisms are only required in the circumstances where we need to resolve the conflict and where we are having multiple decision maker. Okay, so like I am having a network, and in that particular network I am having more number of nodes, let's say for example, but all when it comes to taking the decision, that is my cluster head. I am just taking one example out of the box. So this node is going to take the final decision on behalf of the rest of the node connected to the network. If this is the scenario, then in that particular case, there is no requirement of consensus. Okay, so now consider a situation where you are having multiple decision maker, like in the example that we have considered, that in an Indian family we are having 4 members, and all these 4 members are having 4 different opinions. Okay, like decision 1, then decision 2, then decision 3. So all these are having 4 different opinions. So in that particular case, which decision is to be final? How we are going to decide? So in order to decide that which decision is final, we have to use the consensus mechanisms or consensus protocols, and that is the role of consensus protocol, particularly in the blockchain network. Okay, so in this particular environment, we can say that if we are having multiple stakeholders, then reaching to a common agreement is sometimes a very challenging task. Then in order to reach to a common agreement in a competitive environment or in a multiple stakeholders environment, we require the consensus mechanism. Now the next question comes, if we require the consensus mechanism, then how many consensus mechanisms are there? So like I have already discussed that public environment, then second we are having private environment, okay, and third we are having consortium or federated blockchain based environment. So 3 different network settings we are having in the blockchain. Okay, so if we apply the, if we want to select, let's say for example, in my selected application, my application is government services, and for the government services I have used public blockchain, that is my permissionless blockchain. So in that particular case, I have a separate class of consensus protocol that starts from proof of work, proof of burn, proof of stake, proof of last time. 4 different categories, 4 different class of consensus, primarily 4 different class of consensus protocol. That is proof of stake, proof of burn, proof of work, and proof of last time. Coming to the private, which we can call it as a permission environment. Then we are having separate class of consensus protocol that start from Paxos, Raft, multi-Paxos, chief Paxos, okay, and then Byzantine fault tolerance, practical Byzantine fault tolerance, 3 Byzantine journal problem, 4 Byzantine journal problem. All these are primarily used for the network kind of setting where we are having the private kind of setting where no one can join the network at any instant of time. If you want to join the network, that means you have to perform some kind of work. Now, third category of the network kind of setting is the consortium, which contain a kind of a mixing of public and private kind of setting. So whatever protocols that are applicable to the public as well as to the private, we can frame out a kind of a hybrid approach using the consortium blockchain. So this is a general viewpoint related to the consensus mechanism. So now coming to why there is a requirement of consensus, I have already told you what is the motivation of using the consensus in the blockchain network, because in the blockchain network also we need to frame out we need to reach to a common agreement. Okay, what is the common agreement? Common agreement, like let's say you have started the first round of mining, and in the first round of mining, let's say 50 nodes are taken part in the first round of mining, then how will your system will reach to a decision? Or in order to reach to a decision, you have to come up with a kind of a procedure. That means you have to set certain kind of rulings. Rulings may be if you exceed 51% or more than 50%, then you can consider it as a procedure and you can move forward. So this is going to be a kind of a procedure which we are using in order to reach to a agreement. Okay, so now coming to the real-time applications of consensus, if you refer the literature, then you also realize that these consensus are not a new term. This was very old term. Okay, but because of the inception of this blockchain technology, people are developing their own consensus or customized consensus protocols, consensus mechanism for their defined applications. And maybe the scenario is like that the consensus mechanism that they have developed, this is applicable or suitable only for their defined application. But when you want to apply the same consensus mechanism in the different application, maybe there are chances that it doesn't give the optimum result. Why? Because standardization among these consensus protocols also comes to be a very tricky and research problem. A lot of research is going on in this direction to standardize the consensus. Okay, so now coming to the realistic applications of consensus protocol, what are the realistic applications of consensus protocol? The first and foremost common application of the consensus mechanism is the flight control system. So I will tell you in a very simple way what is and how the consensus mechanisms, what kind of role these consensus mechanisms are going to provide in the flight control system. So let's say if we consider an example, multiple flights are heading towards Ahmedabad airport, and the traffic control system sitting at the Ahmedabad airport, they need to decide which flight is to be landed first, which flight is to be landed second, and so on. So on the basis of what they have to decide, because these flight control system, they have to coordinate the position of the different flights all together among themselves, and how they are going to decide, a lot of parameter you have to consider, like domestic airline is giving the more weightage, whosoever will give the more revenue will be given more weightage. All these parameters I have not taken into consideration. I'm just telling you in a technical perspective, not a bias system. Okay, like Air India is a home airline, so we need to give the higher priority. It is not like that. That kind of constraint we have not considered. Now, how that air traffic control system sitting at the Ahmedabad airport decide that which flight is to be landed first. So in order to resolve the conflict, they have taken the role of consensus, or they have made the uses of consensus protocol in order to reach to a final judgment that which flight is to be landed first. So this is a very promising application of consensus mechanism flight control system. Second application is the fund transferring system. It's a very common application, fund transferring system. What is the meaning of fund transferring system? You can consider any usage or any transfer of cryptocurrency, or you can consider the Bitcoin also. So like if I want to transfer, let's say certain Bitcoin from my account to my friend account, then I, on the basis of what this transaction is going to be validated and verified. So on the basis of some defined procedure. So that particular defined procedure, please, all the participants, I request, please mute yourself. So this is the second real-time applications of consensus mechanism. The third realistic application of consensus protocol is a leader election and mutual exclusion problem. It's a very common problem in the blockchain network. Like if I forget about the blockchain, I will tell you in a very simple way. So let's say for a particular constituency, multiple candidates are contesting for a single constituency. Then how the election commission is going to decide that who is the winning candidate? I again repeat, let's say for a single constituency, multiple candidates are contesting. Then on the basis of what the election commission is to decide that who is the winning candidate, on the basis of the voting share. Whosoever will get the highest voting share, that will be declared as a winning candidate from the election commission side. This is the general philosophy. So what is this? This is nothing but this is one of the consensus mechanism that election commission has used. So this voting, majority of the voting, majority voting is what this majority voting is a procedure that is used by the election commission in order to resolve the conflict between, or in order to reach to a final judgment, final agreement between all the candidate contesting for a single constituency. Okay, so this is also one of the very promising problem where leader election and mutual exclusion problem, where all the nodes collectively select their leader in the system, and then we require distributed consensus mechanism in order to resolve the conflict. So these are some of the applications that I have highlighted here, where they have already used the consensus mechanism. A lot of other applications are also exist where people have used the consensus mechanism. Now coming to why we need consensus mechanism, what is the motivation, I have already described. Now why we need consensus? In order to reach to a final agreement. Now what is the sufficient and necessary condition for the consensus mechanism? So to achieve the consensus mechanism, or to achieve the agreement in a network or in our application, it is highly essential that you require more than two nodes. If you have only two nodes in your system, then it is very typical to reach to a consensus. Why? Because one say yes, one say no. So 50-50%. So this is not a viable solution, or this is not the solution that we are looking for, because 50-50%. So your system will not reach to a final agreement that which one is the final procedure, whether telling by this person X or telling by this person Y. Okay, so that's the way it is highly essential that if you want to achieve the consensus, that means if you want to achieve the agreement in your system, then you always require more than two nodes. Okay, this is the prerequisite for the consensus mechanism. Now moving further, before discussing about the consensus mechanism, let me just tell you very quickly that how many categories of fault exist in the blockchain network. Why this slide is so important for you? Because once we discuss, or once we study about the consensus protocol, now how we are going to segregate these consensus protocol, the first segregation is based upon the type of the network, like public, private, or consortium. What is the second criteria of comparison among these consensus protocol? The second parameter should be the nature of fault that these protocols or these consensus protocols are going to handle. So whatever consensus protocol I am going to discuss with all of you in the next 50 minutes, all these consensus protocols are primarily used for the permissionless environment or public environment, when anyone can join the network at any instant of time, free, open source, open environment. So depending upon the fault also, we can categorize these different category of fault. I will tell you, let me just first complete what is the meaning of these three fault. So in the blockchain network, there are three category of fault exist. Okay, so we will take one by one. first we are going to compare these with some realistic example, and then I will come back to whatever is mentioned in the PPT. So let me just tell you what is the meaning of crash fault. The meaning of crash fault is something like that. Let's say you have deployed 100 sensors in a particular room, and what is your intention? Your intention is you want to measure the temperature of a particular room, okay? And at a regular interval of time, you are getting the reading from these 100 sensors that you have deployed in a big room. So let's say because of network failure, because of some connectivity issue, you are not getting any kind of reading from sensor ID number 37, sensor ID number 69. I am just taking an example, but it may happen practically that over a period of time, you are start getting the reading from these faulty sensors, because network may recover, network may restore, connectivity may be strengthened or connectivity may be restored. So such category of fault, we can call it as a crash fault, where it means that nodes crashes and no data sent to the base station or to the medium that you have used, and it may recover after some time automatically. So this category of fault, we can call it as a crash fault. Now coming to the second category, what is the meaning of this network or partition fault? So let's say initially you are having a single network of 50 nodes, single network of 50 nodes, and because of some crash fault, because of some link failure, because of some connectivity issue, the link between the node number 35 and 36 breaks, and there is no connectivity between node number 35 and node number 36. So because of this connectivity issue, or because of this fault, this single network of 50 node is partitioned into two different networks, and there is no connectivity between these two partition network. Earlier we were having a single network. So this category of fault in the blockchain network, we can call it as a network or partition fault, where your network get partitioned and message from one partition network not gets propagated to the other network. Okay, now coming to the very popular fault in the blockchain network, where people are still working to provide the accurate and appropriate solution for that particular fault, is the Byzantine fault. So what is the meaning of this Byzantine fault? What is the meaning of this term Byzantine? I will tell you in a very simple way what is the meaning of Byzantine. So let's say, for example, at the entry point of the network, you have checked the authenticity of each and every individual user, whether that particular user is legitimate user or not, or at the access point, basically at the entry point of the network, you have some kind of access policies, and through that, these access policies, you are going to ensure that the user, those are connected to a network, those users are the legitimate user or the authorized user. No unauthorized user can get the access of your network. Okay, but in a practical aspect, when we are going to implement any real-time solution for any application, then it may happen that over a period of time, once the authentication process is over, the node started behaving maliciously, or any of the users started behaving maliciously. This is very typical to handle. Why? Because already the authentication process is over, and that particular user and that particular node is the part of your network, and that particular node or the user started behaving maliciously. That means the intention of that particular node is not right. Maybe because someone has given some kind of incentive to him that please do this, perform this wrong activity, or maybe he has joined the part, he or she has joined the part of or team of attacker. So this category of fault is called as a Byzantine fault. It's very typical to handle. Why? Because already the user has joined your network, and after joining the network at certain amount of time, it behaves, or that particular user started behaving maliciously. So there are two categories of malicious behavior of node in the Byzantine fault, particularly because of the hardware fault or because of the software error. Okay. So now if I talk about whatever consensus protocol I am going to discuss with you, all these consensus protocol can handle the crash fault and network fault, but they failed to handle the Byzantine fault. So if you want to handle the Byzantine fault, then we have a separate class of consensus protocol that we can call it as a practical Byzantine fault tolerance, PBFT, and Byzantine fault tolerance, that is BFT. Okay, and in order to handle the crash fault and network fault or partition fault, we are having a separate class of consensus protocol that we can call it as a Paxos, cheap Paxos, multi-Paxos, Raft. Okay, although this is not part of our discussion, but I will tell you a lot of scope available for you people to contribute in the area of consensus mechanism, where you have the scope available depending upon your own requirement. You have the scope available to develop a customized consensus protocol also. Now moving further, now in the next few slides, we are going to discuss classical consensus protocol. What is the meaning of these classical consensus protocol? The meaning of classical consensus protocol means the protocol that are primarily used for the public environment. So the first and classical protocol developed by Satoshi Nakamoto is the proof of work, or we can also call it as a POW. Okay, so if you refer the literature, then you also realize that this protocol was also termed as the Nakamoto consensus. Why? Because this protocol was developed by the Satoshi Nakamoto. So forget about what is mentioned in the PPT. I will tell you in a very simple way. What is the basic philosophy of proof of work based consensus protocol? Proof of work based consensus protocol say that we need to start the mining process. Okay, and I have already told you that what is the meaning of mining process, and the node, those are having high performance computing facilities available, like HPC is available or GPUs are available with them. Their probability that their transaction will be added in any round of mining is much more higher as compared to the rest of the miner. I again repeat, what is the basic philosophy of proof of work? The basic philosophy of proof of work is, here the mining is dependent on the computational resources available to the miner. So it is just like that in a class of 60 students, if all these 60 students want to take part in the mining procedure, then out of these 60 students, if any of the 4 students are having access to GPUs or high performance computing devices, then their probability that they will be the winning candidate for a particular round of mining is much more higher as compared to the rest of the miner or the rest of the students, if I take an example. Okay, so this is the basic philosophy used by the Nakamoto, that your mining is dependent on the computational resources available to the miner. But initially, the probability of getting the proof of work is low. Why the initial probability of getting the proof of work is low? Because initially, when the mining process will start, in any round of mining, we cannot predict, or it is very difficult to say that which miner will be able to generate the block. That means which miner will be the winning candidate for a particular round. Initially, we cannot say. Why? Why? Because it is very simple, that it is dependent on the computational infrastructure available to the miner. So no miner will be able to control the Bitcoin network. If you take an example of Bitcoin network, single-handedly in any round of mining, ideally it will not happen. So this proof of work is using the SHA-256 hash function that we have already seen in our previous lecture implementation also, double SHA-256, in order to preserve the privacy, or these encoded IDs are to be used in order to secure your entire data, preserve the privacy of individual. Now, how this proof of work system works, I will tell you in a very simple way how this proof of work system works. We know that what is the meaning of proof of work. Proof of work means the mining is dependent on the computation resources. Now, why the Bitcoin based proof of work is tamper proof? How will we ensure that if I am going to use the proof of work based consensus mechanism for building my any smart applications or any IoT based application, any network based applications, then how this proof of work based consensus mechanism ensure that tampering of the data in my application never happened or never occurred, or my entire data is safe. 100% we cannot claim at any instant of time. No literature is going to support. Okay, but it is very difficult with the current hardware, you can say. So now, just to tell you the answer to this particular question, we have considered here some fragment of the blockchain. So it is just like that. In my blockchain, I am having 30 nodes, 30 blocks. And in our previous session, we have already noticed that what is there inside the block. So we have defined the block as a class, and inside the class, we have defined the attributes like index, timestamp, data, and previous as. So nonce we have already seen, timestamp, previous as, and this is the way how the next block will store the hash of the previous block. Okay, so this part we have already seen. So let's say we have considered some fragment of the existing blockchain, that is block number 22, 23, and 24, just for the demonstration purpose. So the blockchain together contain a large amount of work. So from the attacker perspective, if you think, if the attacker want to attack in any proof of work based consensus mechanism which is already in place in any of the application, then the attacker need to perform more work. That means the attacker need to perform greater work or more work, more than the total collective work done by all the miners. Let's say, for example, if attacker want to attack in a system, and there we have already placed or we have already used the proof of work based consensus mechanism, then in order to gain the access of the entire network, the attacker has to do more work as compared to the work carried out by all the miner collectively. Okay, that means it is a impossible sometime, because maybe you are having chain of 1,000 block, then the attacker need to work more than the collective work performed by the 1,000 miners. Sometimes it is very difficult, okay, but not impossible. In the recent past also, there are a couple of examples where these attacker has invested their huge hardware in order to calculate the hash much more faster as compared to the hash or the puzzle solved by the actual miners. So if the attacker can do the work by investing a huge hardware which can compute the hash very fast and will be able to change the hash of all the blocks in the blockchain, then this thing will be possible. But in nutshell, we can say that it is very difficult, but at the same time, not impossible. Why not impossible? Because if they have access to the GPUs and all, then they can perform it. Okay, so this is the answer that why the Bitcoin based proof of work is tamper proof, and how this proof of work based system is going to ensure the tamper proof mechanism, which is one of the characteristic of blockchain. Now, there is one very renowned problem in the blockchain that we can call it as a double spending problem. So now, how this proof of work based consensus mechanism solve the double spending problem? I have converted my conversation into more question form. Why? Because then only you people feel understand the concept and feel a kind of a belongingness, that if I convert my conversation into a more questionnaire form, so that things becomes much more easy for you people to understand. So now coming back to our discussion, what is the meaning of double spending problem? In simple, what is the meaning of double spending problem? Let's say I have 50,000 rupees in my account, and I have initiated two different transactions simultaneously at the same time, and each transaction will carry 50,000, 50,000. So this kind of transaction or this kind of problem where the same fund I am going to use twice, but for which I am not entitled because that much amount is not available in my account. So this kind of problem we can call it as a double spending problem in the blockchain. So how this proof of work based mechanism is going to solve the double spending problem? So because the transactions, you know that once the transactions are committed, so they are irreversible. That means it is computationally impractical to modify already committed transaction. Point number one, or reason number one, that how the proof of work solve this double spending problem. Second, every transaction can be validated against the existing blockchain. That means whenever any transaction is initiated, then all the parties, all the nodes are taken into the consideration, and after the mutual consensus or after the defined procedure, then only this transaction is added into the blockchain. That means the every user is going to be taken into consideration, or the viewpoint of every user is going to be taken into consideration while reaching to the final agreement. So to make the system tamper proof, proof of work ensure that double spending problem not occur. This is a very important problem in the blockchain, that how you are going to restrict a particular individual to successfully use the same fund twice. Okay, so like in this particular case, let's say the attacker is having 10 Bitcoin in his account, and he want to initiate the two transactions simultaneously at the same time, and each transaction carry 10 Bitcoin. So this example we can consider as one of the example for the double spending problem. Now moving further, so next one is, what are the problems associated with the proof of work based system? So proof of work based system, when the Nakamoto developed this proof of work based consensus mechanism, then over a period of time, Nakamoto think that this is not a viable solution, or this is not a fair system. Why it is not a fair system, this proof of work? Because the basic philosophy of proof of work is the whosoever will be the winning candidate is to be decided based upon the computational resources available to the miner. So let's say, think in a practical aspect. In a class of 60 students, 4 students are having access to GPUs and high performance computing devices. In the round number 1 of the proof of work of the mining, these 4 students will be the group of these 4 students will be the winning group. Okay, and they decide that whose transaction will be added. Now, when the second round of mining will start, we are using the proof of work, because the basic philosophy of proof of work is the mining is dependent on the computational resources available to the miner. Then again, in the second round, these group of 4 students, they are the winning, and the third round also, fourth round also. So this will create a kind of a problem, or this will demotivate the rest of the miner or rest of the student. Why should we take part in the mining if our transactions are not added into the blockchain? Why should we take part? What is the encouragement for them to take part in the mining? Okay, so then the Nakamoto thinks that irrespective of it, whether you win in a particular round of mining or whether you lose in a particular round of mining, despite of that fact, the network will give some kind of incentive. Why? Incentive to all the miner. Why? Because you have taken part in the mining, and after taking part in the mining process, you have consumed your physical resources like your CPU, memory, CPU utilization. So for this particular purpose, and in order to just motivate you to take part in the next subsequent round of mining, so that the competitive scenario can be created, this reward concept comes into the picture. So how this reward concept or this incentive concept in the blockchain comes into the picture? This is the reason. So I can say the monopoly is one of the problem associated with the proof of work based system. What is the meaning of monopoly? Monopoly means whatever I have told to you, where miner having more resources have more probability to complete their work. So miner will get less reward over a time, and the rest of the user will get discouraged to join as a miner, because what is the motivation for them to taking part? So this is one of the problem associated with the proof of work based system, that is monopoly. And believe me, this monopoly is going to be a worse situation or round by round of the mining, if you are not going to give the incentive to the miner. Okay, and another problem associated with the proof of work based system is the power consumption problem. What is the meaning of this power consumption problem? It means that because in the proof of work based system, we are consuming the physical resources like your CPU utilization, your memory. So that's the way, compared to rest of the consensus protocol, this proof of work based consensus protocol, in this protocol, the power consumption is one of the problem, because we are consuming the physical resources. So two problems are associated with the proof of work based system, that is monopoly and power consumption. Now my next question comes, how to resolve these problems, how to resolve this monopoly problem. So in order to resolve this monopoly problem, which was one of the problem associated with the proof of work based system, there is a new class of consensus protocol, and this new class of consensus protocol we can call it as a proof of stake or POS. This is a second class of consensus protocol that is to be applicable, or that is under the umbrella of permission less environment or public kind of network setting. Okay, so what is the basic philosophy of proof of stake? The basic philosophy of proof of stake is like that if compared to the proof of work. Here, in case of proof of work, the mining is dependent on whatever amount of stake you are having, or whatever amount of stake the miner is holding. So let's say, for example, the entire network worth, 1% of the entire worth of the network, one of the miner is holding. I again repeat, if 1% of the entire worth of the network any of the miner is holding, then he or she is entitled to take part only 1% of the time. Getting my point? It is not only that you are going to take part in the every round of mining, otherwise it is going to be kind of a monopoly. It is not a fair system. So how this proof of work, proof of stake based system avoid the monopoly problem or tackle the monopoly problem? So here the amount of Bitcoin that the miner is holding, the miner, let's say miner is holding 1% of the Bitcoin that he or she can mine, or the 1% of the block. So that is the way how the monopoly problem which was there in the proof of work based system is resolved by using the proof of stake based system. Okay, now moving further, how this proof of work, proof of stake based system, POS system works. So it provides increased protection. How it provides increased protection, this proof of stake? Let's say, think from the perspective of attacker, like in the same way we have discussed in the case of proof of work. Now, considering the same perspective, let's say as an attacker, I want to attack in a proof of stake based consensus system, a system that uses proof of stake as a consensus mechanism. So executing an attack in proof of stake based system is expensive. Why it is expensive? Because you need more Bitcoin. If I take an example of cryptocurrencies, if you want to generate more blocks, if you don't have more Bitcoin, more cryptocurrency, then you cannot take part in the mining. It is as much as good whatever amount of money you are having in your pocket, and if you go to the restaurant, according to that you can order. If you are having 100 rupees, so you can order only 100 rupees. So that is the way how the monopoly problem is rectified or tackled by this proof of stake based system. So it is expensive. Why? Because from the point of view of the attacker, because if attacker want to capture the entire system and that system uses proof of stake based consensus mechanism, then definitely that attacker has to invest huge amount of Bitcoin. That means it is a great loss. It's a huge loss to the attacker also. So over a period of time, it gives the reduced incentive for the attacker, because the attacker needs to own a majority of the Bitcoins, and so that the attacker will have more effect on the. So, okay, so that is the way that how this proof of stake based consensus protocol works. Now coming to the next class of consensus protocol, this is the next class of consensus protocol under the umbrella of permission less environment or public kind of network, that is proof of burn, or we can also call it as a POB. So here, what is the philosophy? If I compare it with the proof of work and proof of stake, here it is one step above to the proof of stake. It is not only that how much amount of stake you are having or how much amount of Bitcoin you are having. According to that, you can take part in the mining. It is one step ahead. How much out of the holding stock? Yes, please. Anyone have any doubt? Shall I continue? Someone is speaking something. Shall I continue? Hello.
Yes, sir, you can continue.
Okay. So in case of proof of burn, what happens basically, it is one step ahead to the proof of stake, that it is not only that the amount of stake or amount of Bitcoin you are holding, out of that, how much you have consumed. That means how much you have burned. Burn means what? Burn means that how much you have spent in order to buy a particular wealth or a particular, or taking part in the mining. So if I talk about in terms of the expensiveness of this particular consensus protocol proof of burn, so proof of burn is expensive just like the proof of work, but no external resources are used other than the burn Bitcoin. So if I compare the proof of burn, because in case of proof of burn, we are not consuming the actual resources like we have consumed in case of proof of work, actual resources like CPU utilization, memory, but here we are consuming the virtual resources. So attacker have also the huge loss of Bitcoin if attacker want to attack in a proof of burn based system. So now the next question comes, how can you ensure or how can you justify that the proof of burn based system are power efficient compared to the proof of work and proof of stake? Because here in case of proof of burn, you are not utilizing the physical hardware like we have utilized in the case of proof of work. Okay, here you are utilizing or you are spending the digital currencies for the same. So that is the reason why it is, this proof of burn is efficient in terms of power consumption compared to the proof of work. Okay, so now whatever I have discussed with all of you, because this is very important part, very basic backbone if any people want to work in the area of consensus, and this is a very grayscale area for all of you to contribute. So primarily we have discussed proof of stake, proof of burn, and proof of work. Three consensus protocol we have discussed. So the basic philosophy of proof of work, just a small recap. It is dependent on the computational resources available to the miner. Proof of stake is dependent to the amount of stake available to the miner, and proof of burn is dependent on out of the stake available to the miner, how much amount of Bitcoin or how much you have burned or you have spent. Okay, so here in case of proof of work, we are consuming the physical resources like CPU, power, and time. But in case of proof of stake, no external resources we have consumed, but to participate only in the transaction. And in case of proof of burn, we have consumed the virtual resources or the digital resources like the coin. So proof of stake and proof of burn, they are power efficient as compared to the proof of work based system. Now you can give one very comparative analysis kind of work to your any of your BTech student, where after analyzing how these three protocol works, they can do a kind of a comparative analysis, and they can implement these consensus protocol in Python or in Java, any of the programming language. Okay, so this is going to be a kind of a good learning for the students also, although a lot of literature also available as far as these consensus protocols are going to concern, because these are very classical consensus protocol. But yes, if you want to work with the industry 4.0, then maybe these protocols are not going to help you. On the top of that, you have to take or you have to coin a hybrid consensus protocol depending upon the application, context, nature, or your requirement of your application. So last consensus protocol under the umbrella of the public network or the permissionless environment is the POET, proof of last time. Okay, proof of last time. So this protocol or this consensus protocol was coined by Intel as a part of their blockchain environment, or if you refer the literature, we can also call it as a Hyperledger Sawtooth, one of the variant of Hyperledger. For what purpose we are using this Hyperledger Sawtooth? Our intention is we want to develop any decentralized applications. So what is the basic idea of proof of last time? How this proof of last time or POET, which is the last consensus protocol under the umbrella of permissionless environment or public environment, how it works. Here the basic idea is just like that. Every participant, it is just like that. As a teacher, I enter into the class and I say that, hey, today we need to elect the monitor of this class. I will give you 2 minutes to think, And after 2 minutes, raise your hand who want to become the leader of this class or monitor of this class. So on the same philosophy, this consensus protocol works. Here, each participant, those want to take part in the mining using the POET consensus protocol. So each participant in the network waits for random amount of time. Okay. And the first participant who has completed the random waiting time become the leader of that particular round to mine the new block. So it is just like that. After teacher entered into the class and teacher say that we need to give the 2 minutes to you to think that you want to become the leader of this class or monitor of this class or not. After 2 minutes, any one student raise his or her hand that I want to become the monitor of this class, then it is okay, there is no problem. Then think the situation simultaneously at the same time, more than one student, let's say 5 students at the same time raise their hand, and they all are claiming that I have raised my hand first, he or she has raised his or her hand after that. So how your system will ensure, how the teacher will ensure that who is telling a lie and who is telling a truth? This is a common problem associated with the proof of last time, that how to calculate the random waiting time, or how to ensure that the person or the proposer is claiming that the ultimate challenge here is what? The ultimate challenge is how will you verify that the proposer, that means the student, has, if we talk about in terms of our example, has really waited for random amount of time. How will you verify? So let's say, for example, if it is a software controlled, you have developed the entire system as a software control system, then in that particular case, attacker may do some kind of changes to the code and may claim that, hey, I have waited, let's say, for 120 seconds before participating in the mining procedure. Then, and once you ask from your system, because it's a software controlled environment, then your system also say, based upon the algorithm of POET, that, hey, this person is telling a lie, and although this person belongs to be an attacker, maybe an attacker. So how will your system will ensure to give the, not to give the any privilege, any weightage to the attacker? So later on, when Intel developed it, this was entirely software control system. Then later on, Intel think that if it is a software control system, then there is a lot of scope available for the attacker to do some kind of changes to the code and can claim that, hey, I have waited, I am the first one who has waited the or completed the waiting time. Then in order to verify it, Intel come up with a kind of a CPU instruction set. They have developed a CPU instruction set, which they call it as a SGX, Intel Soft Guard extension, which is a trusted execution platform, which is hardware code where you can write, but less scope is available for you compared to the software controlled environment. So the specialized hardware provide you a kind of a attestation, a kind of a verification that the trusted code has been set up correctly, and whosoever is telling that I have waited, let's say, for 120 seconds, that person is a authorized person belonging to the network. So this is the entire philosophy how this proof of last time consensus protocol works. So it works primarily both for the permission led. Good part about this consensus protocol is it is applicable both the permission and permissionless environment. That means both the public and private environment. But the consensus protocol that we have discussed previously, POW, POB, and POS, they are primarily used for the permissionless environment. Okay, so this is about the theoretical stuff that I want to share with all of you, that how this consensus protocol works. Now, let me just directly shift to the implementation part, and again we will come back to 2 PPTs are remaining. Then we will come back to these 2 PPTs. Okay, so let me just open the, yeah, I believe that my screen is visible to all of you. My VS Code screen is visible to all of you. Anyone can reply?
Yes.
Okay, perfect. Now, what is the objective or what we need to discuss in this particular implementation? In this particular implementation, we will try to implement the proof of work based consensus protocol. So we will see how the proof of work based consensus protocol is to be implemented in the in the Java, or language is not a barrier. You can implement it in Python also. You can implement it in C++ also. Language is not a barrier. Okay, in whatever language you feel yourself comfortable, you can have the flexibility to use that particular language in order to develop. But the thing is, you need to have the entire in-depth knowledge about the technical concept. That's the way. Sometimes these theoretical concept, although it is going to be sometime a kind of a bore, but believe me, unless and until we know the basic fundamentals of a particular title or a particular topic, then only we can proceed further. Otherwise, there is no meaning to proceed further. Okay. So now certain parts I am just going to skip, because in the previous implementation we have already discussed these part, but some of the part I am going to share here, like in our previous implementation also, when we have implemented the blockchain, we have used the SHA-256. Okay, so in order to generate the hash, so same crypto.js SHA-256, I am going to inline the same in my program. Then I have defined a block as a class, and after that I am defining the attribute of the block as a class that I have defined, the index, timestamp, data, and previous as. Okay, that exercise we have already carried out in the last lab, last session also. Now after defining the class, next step is we need to calculate the hash of the block that we have defined. So how many attributes we have fixed up for the block that we have defined? 4 attributes: index, timestamp, data, and previous as. So this function will return me SHA-256. This will return me a single hash value, which is the hash pertaining to the block. After that, this difficulty plays a very, very important role in the consensus mechanism. This is a new code for you people. So I will spend more time on this particular case. What is the meaning of difficulty? So let's say you are having, let's say, multiple consensus mechanism or consensus protocols available with you. How will you ensure that which consensus protocol or consensus mechanism is providing more security compared to the other? How will you check the toughness of the consensus protocol? So in order to check the toughness of the consensus protocol, this difficulty plays a very, very important role. What is the meaning of difficulty here? Difficulty means the scenario is like that. If I want that my transaction to be added into the blockchain, then network is going to float some kind of challenge, and every miner, the part of the network, trying to solve that particular challenge which was posed by the network, but only one of the miner will win for a particular specific round of mining, and then after that the transaction is completed, we will start for the next round of mining. So what is the meaning of difficulty here? The meaning of difficulty here is how you are going to make this challenge more typical, more difficult, more challenging. If you make your challenge or your difficulty, I can say, much more complex, then your mining algorithm will take more time. Why your mining algorithm will take more time? Because if you make the challenge, if you make the difficulty or difficulty complex, then the miner will have to take more time, will have to invest more hardware, more resources in order to get the solution, because it's a complex problem. Okay, so that means if you make it more complex, then it is very much obvious that security and privacy is going to be increased, but at the same time, much more wastage of the resources at the end of the miners are going to be invested in order to solve that particular puzzle. But at the same time, if you make this difficulty very low difficulty, very low puzzle problem, and everyone is in a position to provide the solution of that particular problem, then you are going to give the invitation to the intruder or the attacker, hey, come and perform some kind of malicious activity. So this is going to be a very tricky situation. It's a trade-off. Neither you can make the difficulty more complex, nor you can make the difficulty low. So it's a trade-off. So how will you set the difficulty? It is dependent on the application in which you want to use it. Okay, so this is the meaning of difficulty. So now how will you set the difficulty? So round by round, sometime some of the applications they have increased the difficulty. Like in this particular case, if we will start from the zero. Zero indicate what? Zero indicate that we are going to increase the level of difficulty or complexity of the difficulty round by round. So in the first round, maybe it is not a much more complex puzzle, but whenever we proceed from one round to another round, then it is going to be a much difficult puzzle or much complex puzzle. Now, after that, after setting the difficulty, now we need to generate the first variable of the array. That will be the Genesis block, or that we need to create manually. In our previous implementation also, we have created the Genesis block manually, which is the first block of the blockchain. So now, in order to implement this particular proof of work based implementation, we have set the difficulty 3, just a roughly number. Okay, I will say that 1 is low and 10 is higher. In between that, I just fix up the difficulty 3. Okay, now after that, I need to, whatever Genesis block I have created manually, I need to assign the attribute to that particular Genesis block. Attribute like index, like timestamp. If you see my highlighted cursor, then the data that you want to store inside the Genesis block, and the previous block, previous, or you can say that previous hash basically. Okay, now after that, what you need to do, you need to check the hash validation. Okay, so hash validation means, just let's say for example, in your blockchain you are having 10 blocks. So you take you start the for loop and go up to the length of the chain and take one by one block, and 2 aspects you need to check. What are the 2 aspects that you need to check for the hash validation? The first one is if the current block hash is not equal to the current block calculated hash. That means certain block is having their current hash, and you are going to match the current block hash with the current calculated hash, which was calculated by the SHA-256. So if it is not equal to, you are going to check it whether it is equal to or not. If it is not equal to, then you have to return the false. Otherwise, you have to proceed. You have to check under that particular case the second condition. If the current block previous hash is not equal to the previous block, why you are checking it? You are checking it in order to just ensure that the proof of work blockchain you are going to create is following the principle of the standard principle of the blockchain, which is what? Which is that the next block will store the hash of the previous block. So manually you cannot check. In our previous implementation, we have checked it manually, but here it is you are expecting from the user that how many blocks you want to create, and depending upon that, you want to set a kind of implementation scenario that you need to check it up to the length of that particular chain, which is already entered by the user. Now, after that, you need to, otherwise you need to return the true value. That means whatever blocks you need to create, the hash validation is perfect, and your entire implementation is following the strategies of the blockchain. Now, after that, in this particular implementation, as we did in our previous implementation also, we have created the 2 blocks. Okay, choice is yours. If you want to create multiple block, you can use here the for loop also. You are expecting from the user, enter the a block you want to create, and you can use the for loop. Under that, you can print one by one the multiple blocks. Okay, choice is yours. So now this is the code to create the 2 block number 1. So what is the index? This 1 is against the index 212020. This is against the timestamp, and my balance 100. This is against the data that I want to store inside the block 1. Same is the case with the block 2 also. And after that, I have created the new block, a blockchain with the name of my blockchain, and whatever block I have created, it is the time to associate all the created block to the blockchain. Okay, so this is the ultimate code or the complete code for the proof of work based implementation. Now let me just check it, and believe me, this is we are going to implement it, or we are going to execute it with the difficulty 3. Okay, and I just brief you that with the difficulty Low difficulty, I have already told you, if you set the difficulty low, then what happen? If you set the difficulty low, then your mining algorithm will not take much time to execute, to mine, automatically mined perfectly. So now let me check it. Oh, the entire proof of work based algorithm works perfectly and you will get the desired output. So output is like that. This is for the Genesis block. This is for the block number 1. This is for the block number 2. Okay, with the difficulty 3. So now I have already told you that if you are going to increase the difficulty, then your mining algorithm will take more time. Why? Because they are going to calculate the solution which related to the puzzle posed by the network. So let's say if I set this difficulty 5 and let me just save it. Okay, and then we will see that how much time it will take, whether it will execute automatically or it will take some time. Okay, so you can see it will take time. The first block will mine, and let me just make this 6. Let me just save it again and let me just implement it again, execute it again. Now we will see that whether it take more time or it execute automatically. You can see it here that whenever we are increasing the difficulty level, the mining will take time. And how many rounds of mining we are having? Only 2 rounds of mining. So the message will display here, the first block creation is going on. That is, the first round of mining is going on. Why it will take more time? Because we have increased the difficulty level. And I have already told you that it is going to be a kind of a trade-off. You cannot fix it more complex. You cannot fix it very low. So you can see this is going to be a kind of a with the difficulty 3 or with the difficulty 6. Okay. So now any one of you have any doubt related to this implementation? Now we will shift to our presentation. So, so now the next question comes that, let's say, for example, after attending this entire refresher course on blockchain technology, you all are highly motivated to use blockchain technology, and you do not want to start alone in the area of blockchain technology. Let's say, for example, you are working in the area of computer vision and you are working in the area of, let's say, network or wireless sensor network, and you want to analyze the area in which you are already working, whether the blockchain is going to contribute in the area or not. So there is no straightforward answer to this question. So let's say if I am working in the area of wireless sensor network and I am very much rigid that I do not want to shift from my area, my core area, but still I want to analyze that how this blockchain technology is going to contribute in the area in which I am already working, or I am willing to start my work. Okay, so this PPT will give you the clear-cut answer to your question that whether the blockchain is the right candidate for this particular application or this particular environment or not. So let me open the pointer also. So when the blockchain is needed, there is a very good paper I found. That paper was written by Osai in 2020, very recent paper, and that paper was published in American Journal of Computer Science and Information Technology. It's an 8 pages paper, but I found very good flow chart in this particular paper. So I want to give the due credit to Osai because they have designed this entire flow chart. So this flow chart is to be used to determine whether a blockchain is the right candidate for you to solve the problem that in which you want to apply the blockchain. So getting the answer to this straightforward question, you have to frame out couple of sub questions like, let's say, the area in which you want to adopt the blockchain. First you need to find out, do you need to store the state? Or that means in the area, is there any requirement to store the state? Or let's say I'm working in the wireless sensor network, cluster head optimization is my problem. So in the wireless sensor network cluster head optimization, is there any requirement of memory, or is there any requirement to store the state? If yes, answer can be yes or no. If no, then do not use blockchain in the area. in which you want to adopt or do not apply the blockchain in the defined area in which you want to find out the adoptability or suitability of the blockchain. If you need some kind of storage in your application that you have identified for adoption of blockchain, then you need to frame out second question. What is my second question? Second question is, are there multiple writers? That means whatever application you have selected in that particular application, are there multiple stakeholders available? Yes or no? Multiples, like if I take an example of healthcare, I want to adopt the blockchain in the healthcare. Then in the healthcare we are having multiple stakeholders like different categories of doctors, paramedical staff, nurses, or your lab technicians. So much diversity is there, complexity is there. So answer to this question is yes or no. If no, in my application, whatever I have selected, there is no multiple writer, multiple stakeholder, then no need to adopt the blockchain. If yes, then you can frame out the third question. The third question is, in your application, always you are using the trusted third party for the data transfer, for the exchange of data, for the exchange of whatever data items you want to consider. That means you don't have any doubt on the integrity of the third party. Yes or no? If yes, then blockchain is not the right candidate for the application that you have selected. If no, you are not using always the trusted third party and you don't have trust on the third party, then are the writers known to each other? That means all the stakeholders, those are the part of your application or those are available in your application that you have identified. All the stakeholders known to each other, they know each other. Answer to this question is yes or no. If they all known to each other, then if no, then you can go with the permissionless blockchain. That means in case of permissionless blockchain or public blockchain, there is no requirement that I know who are my neighbors and what timestamp I am getting the data. Okay, so it's an open environment, and if it is an open environment, then there is no requirement to know who are my neighbors. If yes, all the writers or all the stakeholders are known to each other, then you need to frame out another question, that are all the writers trusted? That means all the stakeholders are trusted to each other. That means there is no requirement to establish the trust in the environment. All the stakeholders are known to each other, and as well as they are having a trust among each other. If yes, then also there is no requirement to adopt the blockchain. If no, the writers don't have trust on each other, that means the stakeholders don't have trust on each other, then you need to frame out the last question, that is the public verifiability required? That means after every round of transaction, is there any requirement to verify each and every transaction? If yes, then you can go with the public permission blockchain. Otherwise, you can go with the private permission blockchain. So this is a very important slide for all of you to understand whether the blockchain is the right candidate for you to apply in the application which you have selected, yes or no. So this will tell you the exact answer, at least ease your process to explore the possibility of adoption of blockchain in the application that you are going to select. Okay, now moving further, recently, if you see, all of you are aware about that, recently our honorable finance minister, she has already declared the adoption of cryptocurrencies, not exactly the cryptocurrency, but the digital currencies by the State Bank of India, okay, or the Reserve Bank of India. So if you just Google it, what is the vision of Government of India towards adopting the blockchain for the different verticals, then you also realize that NITI Aayog and this Ministry of Electronics and Information Technology in the February 2020, January-February 2021, they have already finalized the vision document of adopting the government blockchain in the different verticals. There they have already identified these many applications, and under these applications they require a kind of a strong support from the industry and academia. Okay, so this is the potential applications of blockchain of national interest of our great India. Like if I talk about in terms of each and every application, then it will take another 2 hours. But let me just very quickly summarize very briefly about all these applications, because this is a final takeaway for you people. because all these are very unique applications. Like in India, we also realize that the same land is sold multiple times. At the same time, on a particular land, this particular land belongs to be, chances are belongs to be multiple ownership. Okay, so this is not a new fraud. This is a very old fraud. So government want to reduce the chances of this particular fraud. That's the way the government want to adopt this decentralized mechanism in the property record management, that is the land record. Second promising application is the digital certificate. What is the meaning of this digital certificate management? Here, if any post advertise, then you need to fill the application, you need to do the Xerox of all your credit certificates and then send the application through speed post or courier. Okay, and then once you get selected, then third party will do your verification, or if you selected in government, then police will do your verification related to your social status, related to your crime or everything. So now if you take an example of a very small country like Estonia, in Estonia, there is no requirement to carry any document. There is no requirement to carry any CV. Why? Because they have converted their entire government services to the decentralized blockchain environment. Okay, just a minute. So this is the second application that government of India has identified, and they need a kind of a support from your side with respect to this application. Then the pharmaceutical supply chain, like in the case of COVID-19 vaccine distribution, how the central government will ensure that they have released these many doses to the, or lot of doses to a particular state. How will they ensure that whether the government is using, the state government is using these doses as per the requirement or the plan prescribed by the central government. E-notary, in e-stamping also a lot of fraud is we have observed in the recent past. Government want to develop a blockchain enabled e-sign solution where there is no requirement to have any purchase any kind of NGS notarized judiciary stamp paper, and you need to do it by every party is there on the blockchain. Farm insurance, lot of fraud already noticed in the recent past in the insurance sector, where people have done a fraud or settled or claimed the fraud or a kind of a faulty insurance. Identity management is very promising application. Power distribution, it comes to be the smart grid side, where you can have the demand response management, smart home or renewable energy sources. Then duty payment, agriculture and other supply chain. E-voting is also very promising application, decentralized distributed e-voting system. Electronic healthcare record system, because in India we are following the personal healthcare record system. Let's say for any reason I am living, let's say in Delhi, and for whatever be the reason, I shifted my family from Delhi to, let's say, Mumbai. So whenever I settled at Mumbai and then I encountered any particular disease and I visit the doctors available at Mumbai, so they will treat me from the scratch. They will ask me what kind of allergies you are having. They take my whole background since my childhood, because in India we don't have any healthcare record management system. But the country, like if you take an example of Europe, like let's say I am living in Warsaw, the capital of Poland, and I shifted my family from Warsaw to Berlin. Okay, so there is no requirement to carry all these medical records kind of thing, because they are following the electronic healthcare record system. So they are providing the SSN number to the individuals, citizens, and whenever you visit any hospital or any PSC, then you just need to give the SSN number, and whenever the doctor or any technical staff they enter the SSN number, all details since your childhood will appear, that what kind of drug allergy you are having, how many surgeries already carried out, something like that. So this particular we can call it as electronic healthcare record system. So government of India want to build up the electronic healthcare record system, but the country like India, where population is 130 plus crore, it's very typical, because if you just Google it, then you also found that Russia is daily targeting the healthcare record system of USA. Because as a company owner, if I am a drug manufacturing company owner, And by getting the access to this electronic healthcare record of all the country citizens, I can visualize that over the next 10 year or 15 year, this disease is going to be increased. So based upon that, I can start the early invention of the disease, of the vaccine or the drug related to that particular disease. Then it is going to be a win-win financial model for the companies. But this is not the, so that's the way the security and privacy of handling this electronic healthcare record is going to be a big challenge for the nation. Then digital evidence, public service delivery, IoT device management and security, vehicle life cycle management, cheat and fund. In the recent past, we have already observed a lot of fraud in the cheat and fund. So government want to create a kind of a decentralized database where all these cheat fund operating companies, they are coming on a single platform, and the government act as a regulatory body for these, so that they will not just go away from their responsibilities, and they are not giving the money back to the investors. Okay, so these are some of the applications that the government of India has already identified. So just to conclude, last word that I want to say, if anything I have said seems useful to you, I am happy. If not, don't worry, just forget all about it. This was said by Honorable Dalai Lama. But in slightly in my context, I have changed it, that if anything I have said seems useful to you, I am happy. If not, don't worry, soon all becomes necessity for all of us because of the rapid change in the technology in the present era where we cannot sit silently. So thank you very much once again to the organizer for giving me this opportunity to share my view related to the blockchain. Particularly in today's session, we have discussed about the consensus mechanism. Okay, so now any one of you have any doubt, please unmute yourself or ask your doubt directly. Yes, now organizer, over to you if they have any doubt.
Okay, thank you, sir. If any participants have any doubt, they can ask to sir.
Yes, if you have any doubt, you can write in the chat window also. Let me open the chat window also, or you can unmute yourself. You can ask directly also. And I have also one session tomorrow also. And tomorrow we are going to see that how we are going to build up the smart contract. So tomorrow's session is completely hands-on. In the first few minutes, we are going to discuss about the technical aspects of smart contract, and then we will discuss line by line how you are going to build up the smart contract in a particular development platform. So how we can use it in agriculture supply chain management? In agriculture supply chain management, there are lot of applications, like you can because in the supply chain, you agree with me that there is a lot of intermediary stages are there. Okay, so if there are a lot of intermediary stages are there, then how can you ensure the trust among the different stakeholders? Let's say, for example, if I consider one of the in the supply chain, let's say the company who is manufacturing a particular product, and whenever the product reaches to the end user, it has different phases. Let's say 6 to 7 phases. I roughly just I'm taking a number. Now, how will you ensure that whatever product is developed by the company side, and how the company is going to get the feedback, genuine feedback from the end user side, and how the company is going to ensure that whatever they are going to provide to the end user, whether the end user are expecting the same or not, there is a kind of a communication gap available or not, or how to establish the trust in a different stages of supply chain. So these are some of the area where people have already adopted the blockchain, particularly in the agriculture supply chain or food supply chain, drug industry, drug supply chain. A lot of other examples are also there. And yes, this blockchain is going to contribute a lot in the area of agriculture, not only, but in the area of precision agriculture also, or the precision irrigation also. Yeah. Next question.
Is there anyone who has doubt?
Yeah, if you have any doubt, you can write in the chat window, or you can directly unmute yourself. You can ask your doubt directly. See, I will tell you in a nutshell that in the area of blockchain technology, the hype is more, okay, but the reality is very less. When you go for the implementation, then you found that it is very challenging, very tricky. So that's the way in nutshell, I will tell you that in the area of blockchain, the hype is more, but the reality is very less. Okay. So any one of you have any doubt? Otherwise, the session is end from my side. If you have any doubt, then we will take your doubt. You can write in the chat window or you can directly unmute yourself.
Okay, sir. Thank you very much, sir, for sharing. Okay, sir, we have one question from the Yogesh Kapuria.
Yes, do we need blockchain when all users are authorized prior to access the system? Do we need blockchain? So it is just like that the basic cryptographic primitive this blockchain is not going to replace. Like the basic cryptographic primitives are like that you have the authorization or the access policies or access defining policies. Same you are going to use in the blockchain also. On the top of that, you are going to make a kind of a distributed ledger, but it is not going to replace all the basic cryptographic primitive, but on the top of that it is going to apply the principles of maintaining the trust. Like you can do the trust calculation also. You can define your own metric related to the to maintaining the trust, because sometimes this trust metric calculation plays a very important role when it comes to develop the entire complete framework that will be responsible to provide security and privacy to the not only to a specific user but to all the stakeholders. So these access control policies or these authorization principles remain same. There is no problem at all. We are not, this blockchain is not going to replace them. So I think we will stop now. And once again, thank you very much, all of you, and have a good day.
Thank you very much, sir, for sharing your full knowledge with us. Our next session will be start within 5 minutes. Our speaker is Mr. Yash Sharma. He will going to teach us the blockchain platforms like the Ethereum, Hyperledger, IOTA, and EOS. He will join within 5 minutes. Thank you, everybody. Hello, sir.
Hello, good morning.
Good morning, sir. Am I audible, sir?
Yeah, clearly. Am I audible?
Yes, sir, you are. So we are going
Okay,
to
great.
start our
Thank you.
session number 2, and our speaker is going to teach us the blockchain platforms like the Ethereum, Hyperledger, IoT, and etc. Sir, over to you.
Thank you. So, thank you all for joining, and hopefully, we are all um, aligned to the agenda today. I will expand on the agenda a bit more than what was expressed earlier. Before I get into the specifics of what we want to do today, just want to understand if whatever we discussed yesterday is number one, clear, and if there are any follow-up questions, then we can visit those right now before we jump onto the next topic.
If any participants have a question from the yesterday's session, overview of the blockchain implementation, they can ask here so that sir will clear your doubts.
Feel free to type your questions in chat if that is what you are comfortable with, or feel free to speak out also.
If any participants have doubt, they can write your doubts in the chat box, as well as you can unmute your mic and ask to sir.
Okay, if we are all clear with it, I can talk a bit about what we want to do today. Before that, just a quick recap of what we were doing in the last session. We had talked about the implementation of three basic ideas that resulted in the concept of uh, blockchain being realized. We compared uh, the bank domain and how it operates and what its challenges are to our proposition of the blockchain ledger. And then we went on to understand how three different pillars of technologies, digital signatures, cryptographic hashes, and peer-to-peer networking, how they come together to create for us this technology proposition. Towards the end, we um, took a look at how we can build a very simple, almost trivial demonstration blockchain, which captured a very basic idea of proof of work incentivization through managing the difficulty level that we can set up for a typical in-memory blockchain solution. So we tried to cover a lot of things yesterday, and some of it was hurriedly done, especially around mining rewards and how distributed blockchains work. So we may potentially revisit that during our discussions today and maybe in the later sessions to elaborate some points that that we may need clarifications on. Having said that, what we want to do today is get into the specifics of um, important blockchain frameworks. And when we say frameworks, what we mean is that we discussed the idea of blockchain at a very high level in the last session, as in we did not say that this is the Bitcoin blockchain we're talking about, or we did not say that this is the Litecoin blockchain that we're talking about. These are specific blockchain types that basically implement that idea that we had discussed. From today, we will get more specific, and we will have to discuss a concept called smart contracts, which is basically why blockchains have become so important, before we get into a specific framework of choice for us. So I'm pretty sure that you all must have heard of smart contracts and how they have made blockchains very important and kind of convincing as a proposition. And what we need to do is understand how um, different types of blockchains support the idea of smart contracts differently. And what we need to understand to be able to do that is first understand the limitation of the blockchain types that basically um, talk about a very simple transaction entry and not execution of a smart contract. So having said that, let me present my screen. Let me know once you can see my screen.
So it is visible.
Okay, thank you. So if we want to understand and relate to the idea of blockchains that we established in the last session, one thing that we need to know is that when we talk about a bank ledger, then bank ledger stores a very generic or very simplistic kind of data. In its most simplest form, we looked at that transaction yesterday. The entries were to, from, amount, and timestamp. And that completely represented a transaction entry that a are that a typical blockchain could store, especially for our banking use case. And when Bitcoin blockchain was conceptualized, it was defined as a peer-to-peer digital cash system. So it was talking about cash. It was talking about money transfer. And because it was talking about money transfer, it was enough for the Bitcoin blockchain to store a transaction is just in this very simplistic sort of format. So yesterday we looked at the transaction structure at a very high level, and it looked something like this for us. Or we want to expand it like this. The deposits, withdrawals, and transfers. Those are basically the two types or three types of transfers that we thought of. And in blockchains, a deposit and withdrawal is also very similar to a transfer, where if you're depositing, you would be depositing money from an account that exists on the blockchain to a different, or maybe to your own account. So it's very much like receiving, being the recipient of a transfer. The same thing for withdrawal. You'll be basically sending money from your balance to someone else's balance. So that's the sender side of the transfer. Having said that, as Bitcoin blockchain became more and more popular, this became very limiting for the applicability of the blockchain idea. So if you look at it, this transaction entry is just storing a number, which is this amount. The rest of it is just like the two ends of the transfer, from and to. And then obviously it is time stamped. But if we want this entry to represent something more, then we are blocked. We cannot, if we have this transaction structure, we cannot represent the amount to be anything other than a quantity or a stored value. And because of this limitation, till the time Bitcoin blockchains were the only blockchain types, blockchains could only be a money transfer system, nothing beyond that. You could only implement a bank-like scenario using blockchains. And it was realized that this is obviously limiting the capability of blockchain as a technology. And there is a need to start supporting transactions as they are understood by computing by and large, as in the transaction should represent more rich data than just numbers. And what was felt was that if we are able to, instead of just storing like this simplistic number, if we are able to store, let's say, some data that either just represents some real world asset or some data that is executable or a combination of both of these, then we can find a lot of applicability to our idea of blockchains. So in such a scenario, what was proposed was that let us start, instead of storing that simple number, let us start storing some more data instead of that. Let us change the structure of the transaction or the structure of the entry, and let us start storing either some data that is static data or anything that can be executed. By executed, what we mean is like executable code that can run on uh, digital systems or computing devices. So we have this ledger that's representing our ledger that we had talked about, where there is one address and there is a balance of that address. This is a slight change in the ledger type, which just has transactions. But think of this as like a new kind of ledger that stores balances along with transactions. Now, instead of, let's say, the balance storage that just might store a number, let us store an executable snippet of code also. Now, what that would do is that would allow us to make blockchains in a way programmable or runnable. For example, if let's say we we have a blockchain that's storing those numbers, and at one location there is also a small piece of program or code, then by the very fact that you're storing code there, what you have done is you have made it possible for everyone to inspect that code and have the level of transparency that we had said that blockchains have, which is that everyone can see what is in that code. Everyone can see how it will be executed, because that code is just out there, and it is possible to actually confirm that given certain parameters, the code is going to behave in a certain way. That is what is meant by smart contracts. Now, smart contracts are basically the name given to this code that you deploy on the blockchain. And this code is not in any way smart or can only represent a contract between two people. It can also represent a real world asset or a real world entity. Just like in object oriented programming, we create objects that are reflection of um, real world things around us. So having said that, if we change our ledger idea and we start introducing ledgers like these, the one thing that can happen is that any um, snippet of code, number one, you're just storing it. We're not talking about executions as yet. It can be stored and inspected. So we've established that blockchains are very transparent records of data. It is very easy to um, for anyone to look at it and say and assert or confirm that the code at a certain data storage on the blockchain or data storage location on the blockchain is this. Now, the question is, why do we call them smart contracts? The reason is that they're obviously better than the code that runs in legacy systems for multiple reasons. Because no one can verify what you're running. When you talk about, let's say, uh, online services like social media, social networks, we don't know what code they run. No one can inspect and confirm. We talk about search services like Google or Bing. We don't know how they perform those searches and whether their results are fair or not. These contracts that are inspectable, auditable, when they will run, everyone can know what they are going to do because they can see the code. It's on the blockchain, transparent, unmutable or immutable. The second thing is, if we want to run this code, we can also ensure that the output and input of the run can be stored on the blockchain. What that means is, let's say I write a small program, which is basically a rent agreement between me as a renter and a landlord. And in that, I write um, some basic field level parameters like rent amount, frequency of rent, and then I write one function which is pay rent. And then what I'm basically agreeing to is that every month I will pay, or I will execute the parent function, and it's going to debit, let's say, my bank account and credit the landlord's bank account with the amount that we have agreed upon, which is also a part of the field. Now, if I write this code, it has no value. I mean, who knows who will execute it, whether whether anyone will execute it or not, and who knows if someone changes the rent and then executes it, in which case either me or the landlord would be at a loss. Now I write this code and I deploy it on the blockchain. What that does is it ensures that both me and landlord are agreeing that this is the rent and this is the frequency, and the process of paying rent is by calling the function pay rent. Just the fact that I've deployed it on the blockchain kind of represents a contract between multiple parties that are a part of that code. So that's why they're called smart contracts. You can, I mean, you can represent your code or your contractual obligation in a programming language or in any executable language, and then you make it inspectable and auditable, and you also control its executions. So um, this is a little more detailed, but yeah, this would be a good sort of a comparison. So if, when we talk about contracts, not smart contracts, but contracts in legal terminology, then a contract consists of two things, an offer and an acceptance. So in our legal terms, that offer would be, hey, I agree to pay this much rent. The acceptance would be the landlord saying, okay, I will lease uh, the room or the facility to you for the offer that you're making. Then when both of these are accepted, it becomes a promise, which consists of two entities, a promiser who's making the offer and the promisee is accepting it. Now there's always a part called a consideration, which is what is it that is going to be agreed upon. For me, the consideration is the facility. For the landlord, the consideration is the amount of rent that they'll get. So the consideration plus the promise, that becomes an agreement. And basically an agreement, if you want to formally describe it, it lays down what is the consideration, what is the promise. And since promise has both or all the parties that are a part of it, the promiser and the promisee, the agreement also lists those. And any agreement that is built in such a way that it can be enforced by going to court or by going to a tribunal or by going to any arbitrage party, um, that becomes a contract, like a legally binding contract, because it can be enforced. So you have to write it in a way what should happen if someone breaks a promise, what should happen if someone changes the promise, what is the definition of consideration in the agreement. So when it's written in such a way, it is made possible for uh, someone to legally enforce it. Now, we've talked about multiple things: the promiser, promisee, consideration, the terms of the contract, and all the parties involved. If we define it in such a formal way, it is very easy to convert it into a digital representation. Just as I described, you can create a contract in, let's say, your favorite programming language, JavaScript, in which you define who's the landlord, who is me. You define the consideration, maybe the name or address of the facility and the amount of rent. You define the terms. Terms are the frequency at which rent will be paid. Terms could also be what happens if the rent payment is delayed. Is there a delay fee? And then you define any third parties. Obviously, we don't have third parties in this specific um, contract situation where there are just two individuals, but there could be some interested parties also. So convert this into JavaScript or any script or any uh, programming construct and compile it. You've got your contract, um, and it's a contract that you can execute. Now take this digital representation and create a blockchain transaction in which instead of money, instead of 200 bitcoins or 2 bitcoins, what you store is this JavaScript file or this compiled C++ file or this compiled Java bytecode. And that transaction makes an entry on the blockchain along with this compiled code. So we're talking about a very small and simple code. That's why I mentioned snippet. Because obviously blockchain, when we're talking about blockchains, the data that you store, it needs to be limited by the storage capability. So you store small amounts of data like simple agreements or simple definitions of consideration or assets. And once you've expressed it in your programming or logic construct, you just put it on the blockchain. Now what happens is you got all the capability to inspect it that I talked about. What you also get is the ability to execute it. So we talked about pay rent as one function in your in your um, representation of the contract. It should be possible to send another transaction to the blockchain that calls parent. So when I say calls parent, I'm requesting you to go back to what you've learned about programming languages, where you create routines, functions, methods, and then you create clients for them, which call them. So this is what you can do as a part of a transaction call as well. You create a client that is in a position to create a transaction that's going to trigger the function call on the blockchain. Then what happens is this transaction, which is going to make an entry on the blockchain ledger, is going to trigger the contract or the logic that you've deployed on the blockchain. And it will also store the output of whatever is the execution that you define. And you've got yourselves a programmable artifact or programmable system that can, act a little more than just a regular static data store. So having said that, any questions on this very basic idea? So the reason why I stopped the presentation is that sometimes I'm not able to observe the chat. If anyone's typing anything and I'm in the presentation mode, I will not be able to see what you type. So feel free to interrupt me by going by unmuting yourself and just asking
No,
me to
sir.
read the chat. All right, so we talked about how we can deploy the contract and how we can call it as a client. What now we've done is, if let's say we have a contract which is deployed at this location, I've basically made up a location, and I've called it with parameters like pay rent for June. So this ABC would be June month. This transaction would be stored on the blockchain, which can tell anyone who's inspecting the blockchain that at this day and time, this contract was executed by so and so account, and the parameter that was accepted by the contract was June, and the contract executed, and the output of that execution was also stored with the transaction. Now, if we are able to store this kind of an entry on the blockchain, then what we made it possible, what we made basically, or what we've ensured is that whenever we need to prove that we executed a contract that we entered into with someone, then we basically did our part, or we paid the rent, or we paid the bill, or we completed the assignment given to us, whatever the contract needs us to do. And it becomes obvious by its very nature auditable because it's on the blockchain. No one can change it. In fact, it doesn't need to be audited also. If you made that transaction, the reason why we have audits is to ensure that it's complying with the structure and the format. The very point that you've been able to successfully execute the transaction itself uh, makes the whole idea transparent and introduces accountability. So you may not even need to worry about, as a landlord, you may not even need to worry about the fact that my rent has to be collected, because the contract itself will ensure that someone should be executing this transaction every month. If they don't execute it, there is like the terms that I've written in the contract execution that are going to kick in. So all of what we have to do to ensure that regular contracts that we enter into are executed, all of that can be saved. We don't ever have to litigate and go to court and get into expensive settlements and legal um, activities if we are able to use blockchains to enforce contracts. Having said that, now we have to take a small sort of um, a jump. So there is a lot to understand about what kind of contracts are possible, and we've talked about rent contract. It is possible to imagine a lot of other contract types, like you could have voting or election contracts. You could have brokerage contracts or asset tracking contracts. But the point is that we have made another additional proposal to our blockchain capability. How do we implement it? So there are two basic types of blockchains that represent this idea of smart contracts and executions. One of them is called the public blockchain. So we've been talking about Bitcoin and some of the others like Litecoin and so on and so forth. There are at this point, I think 2000 odd blockchain types that represent different kinds of cryptocurrencies. The thing to know about them is that they are public, as in anyone can be a part of that blockchain. There is no eligibility check. You, if you are interested in mining and earning cryptocurrency as a result of mining rewards, you do not need to do or get approval from anyone. All you need is the capability to connect, which is internet connectivity, and the right kind of hardware. And you can hook up to Bitcoin, or um, you could hook up to um, Zcash. All these examples are examples of that public network that I'm talking about. So the reason why they're called public is, number one, there's no eligibility check. Anyone can be a participant or a node in the network. And the other thing is, no specific node has any additional rights or capabilities. All nodes are the same. So if you set up your node for Bitcoin blockchain, the only distinguishing factor between your node and maybe another node in North America would be that maybe your node would be faster or slower, depending on what your computing capability is. Other than that, all nodes are the same. Now, the fact that we have, public blockchains also, um, and the fact that we have public blockchains and the blockchain data is very public, anyone can see it. that also introduces an issue which is related to data privacy and data control. So imagine that I, um, being uh, being someone who wants to set up a blockchain and float my own cryptocurrency, um, it makes sense for me to introduce that to the public so that my cryptocurrency finds acceptance. But imagine if I want to introduce uh, a cryptocurrency for my company, and I do not want anyone to have access to that currency outside the company, then it will be very difficult for me to use blockchains, because the only option I have is to use a framework that can be accessed by anyone, and anyone can hook up to it. So this kind of brings in a need to uh, offer a different kind of blockchain frameworks. So let's say if we're talking about um, this cryptocurrency use case, there are multiple different currencies that are out there that work more or less in the same way. You've got Bitcoin, you got Ethereum, and they typically operate on a way in which every participant is rewarded for the mining work and transaction verification work that they do. But at the same time, all the people or all the use cases that basically require me to uh, to keep a level of privacy intact when it comes to my data, that issue is still there, and it needs to be solved. Okay, I have a question on chat. Sir, where will you store the outcome of the transaction? So that's a good question. We have not, obviously, we've not explored the idea of contract execution enough. We jumped onto public and private blockchains. But what happens is, if we deploy the smart contract, um, the only way to call that smart contract is by creating a transaction in a certain format whose output is going to be something that the client will look at only after reading the blockchain effects of that transaction. So let's say if I store, if my smart contract is operating, is basically defining my identity, let's say my first name and last name, and there is a function in that first name and last name logic that says update if my last name needs to be updated, then the transaction outcome and the original instance of first name and last name that I stored, both of them are on the blockchain. So when I deploy this contract, its field variables are stored on the blockchain. And when I call, let's say, an update on those field variables, then that update is also stored on the blockchain. So if, let's say, my first name is John Doe and I want to change it to John Smith, then the first instance, which is John Doe, will be stored on the blockchain. And then after the transaction is executed, and now the field variable value is John Smith, that is also stored. So all the outcomes, that is updates that the contract makes to the data that you're storing on the blockchain, that is on the blockchain also. So your contract has to ensure that whatever it needs to constantly view and manage, that should be a field or an instance or a storage variable in your contract. And we'll take a look at how all of this is done when in the last session we are doing simple demonstration contracts on Ethereum or Hyperledger. So it'll become very apparent then. Hopefully that answered to some extent the question. It's a good question. Obviously, we need to explore the contract flow a bit more. So coming back to, thank you. So coming back to what we were talking about, I don't want to discuss the legality at this point. The idea of public blockchains and what are some of the problems that their public nature is going to introduce for me. As someone who's, let's say, running a business or running a corporate entity or an enterprise, there is always a need for me to, number one, control the data access. I don't, it's possible and completely practical for me to expect that the enterprise data that I maintain, it should not be accessible outside the enterprise. And then there is also a need for me to require that um, the entities that are a part of that data creation, who are allowed to basically create that data, they are identified and known. And these are completely opposite to the idea of public blockchains, which say that data is visible to everyone and anyone can be a part of the network. So with this limitation, another proposition was made in after 4 or 5 years of Bitcoin um, Bitcoin journey, which was that we should have a class of blockchains that focus on, number one, access control and hierarchy of the nodes that are introduced as a part of the blockchain, and also that are able to control the access to the transactions or smart contracts that we deploy on the blockchain. These are sometimes called consortium blockchains. Sometimes they're called private permission blockchains. They all basically mean the same thing. What they propose is that when you set up a private blockchain, you set up that blockchain with a configuration in place that allows you to validate every node or every entity that wants to become a part of the blockchain. That's one. Then it allows you to control who all are calling the smart contracts, who all are not calling, who are not allowed to call the smart contracts that you deploy, and also control who all can see the transactions and their outcomes that are there on the ledger. So private blockchains or private permission blockchains, they introduce a way in which, number one, nodes can be different. They can have different levels of access. And number two, the node itself needs to um, be validated, as in to be a part of that network. They go through a process of onboarding or validation, sometimes automated, sometimes manual. So such blockchains, um, they make it possible for organizations and enterprises to adopt them. We will be referring to them as private blockchains going forward. So one thing that needs to be understood, and this is a critical difference between private and public blockchains around how they operate, is that private blockchains can choose to be a little less lenient when it comes to um, maintaining, or when it comes to putting in place um, logic that basically keeps the blockchain consistent and honest. So what does that mean? Uh, when it when we were talking about mining yesterday, we discussed the concept of um, difficulty. Difficulty is the amount of work that has to be done um, to commit a block on the blockchain by a node in order to receive the reward that they are due. So in public blockchains, uh, how it operates is that number one, the blockchain logic itself defines that any node that is able to accept transactions, they can they have to basically send those transactions to a transaction pool. And when there are enough transactions, we will create a block. Very similar to how we had thought about blocks in our bank example. So we create a block of those transactions, and then all the nodes, they will have to get into a kind of a race in which they will identify a nonce that's going to satisfy the verification process. They will have to find a nonce that has that specific format like 0000. So they will have to repeatedly calculate hashes. And the moment a node finds a nonce, they can basically submit and broadcast to everyone that, hey, I found a nonce, and this block can now be committed with this nonce. If you want, you can check my assertion that this nonce is a valid nonce. Everyone who receives that broadcast, they quickly add the nonce to the block data and then verify that it results in a hash with the right number of zeros. And the node that submits this block first gets the reward. In Bitcoin blockchain world, that reward is 5 Bitcoins, which is huge when it comes to Bitcoins. At some point, it was $2,500 or 200,000. I mean, it was a huge amount. So in this race, the winner who basically gets to that nonce the fastest, they win the reward. And then everyone has to drop that block because they are all, along with the rest of the network, they're all calculating nonces, looking to reach the right nonce quickly to earn the reward. But the moment the winner is announced, the rest of them have to drop whatever they are doing and work on the next block. So this process keeps the blockchain consistent and honest. But at the same time, it consumes a lot of, so you all must have heard of the ecological concerns around how proof of work blockchains operate. Bitcoin blockchain consumes a lot of computing power and hence a lot of electricity, because all of these nodes, they constantly calculate hashes, and then I mean, that's all that they do day in, day out, calculate hashes, and so on. So a lot of the electricity is obviously wasted because there's only one winner. The rest of them just, repeat the process again for the next block. So this electricity that's wasted is a price that has to be paid because the blockchain is public, and there'll be people who will try to replace the blockchain or steal, parts of the blockchain, or basically try to um, subvert the blockchain process. When it comes to private blockchains, this problem is not very acute, because when you're operating a private blockchain in within the confines of the intranet of a company, then you can be assured that not everyone in the company will try to hack the blockchain. So it is fine for you that you do not implement a scheme like proof of work to establish the honesty of the blockchain. You could implement something simpler. And because of that simplicity, you can make the blockchains operate at a high level of scalability. when it comes to Bitcoins, usually it takes 10 to 13 minutes for a block to be submitted. Um, the same thing is not needed when it comes to private blockchains, because if we are implementing a system that basically validates a block before confirmation, and you end up spending 10 minutes in that validation process, it's a big bottleneck. So if we want to think of an alternate way in which we can make blockchains faster, purely because they are private blockchains and we can be sure that no one's going to try to hack or subvert the blockchain, then you can implement a different validation mechanism. So what I just described around the validation piece, that is also called consensus. So you'll hear the term consensus a lot when it comes to blockchain technology. And consensus is not a term that blockchains or the idea of blockchain has implemented for the first time. Consensus a um, is a concept that relates to distributed computing. So whenever there is a network that we're talking about, where the network is supposed to execute a use case, then the components or the nodes of that network, they need to arrive at a unanimous agreement on uh, the state of the network. When it comes to, let's say, banking, and if the bank implements a distributed database, then the balance of a certain account has to be agreed upon by every component of that distributed database, or every instance of that distributed database. It's not possible for one database to say that I have $200 and the other one to say I have 250. So they have to agree on the right balance that my account has. Similarly, in blockchains, um, when a block is committed, it needs to be broadcast to a minimum number of nodes, and those nodes have to agree that this is the right block before it is actually made a part of the blockchain. And that agreement is called consensus. The idea of proof of work is basically what you represent as validation when you're arriving at that consensus. And what proof of work does is it introduces a concept called Byzantine fault tolerance. So I'll just take 2 minutes to describe that, and then we'll jump to Ethereum, Hyperledger, and some of the other discussion points that we have on agenda. So when it comes to distributed networks, one of the things that the network has to provide as capability is resilience. What is meant by resilience is that in the scenario of failures, in the scenario of outages, how does the network work? So let's talk about network, example of a network as internet. So internet continues to function even if lots of different servers are down, or if they are offline, if you're not able to connect to them. Even if entire country is offline, the internet continues to function. What this means is that internet is crash fault tolerant. Crash fault tolerance means that it can survive crashes um, of various components that constitute the network. Something similar is there in most of the uh, corporate or private corporate enterprise data stores or service capabilities. When it comes to a bank, the reason why banks have multiple data stores or multiple data centers is that they are looking to create a crash fault tolerant system. If um, one data center is down, the bank should continue to function without it. So having said that, I mean, it's kind of an obvious thing to imagine that if you want to introduce or build a crash fault or fault tolerant system, um, you just ensure that the crash is detected and then the system no longer sends request to that crashed component. Now, this is something that's obvious, but there might be a different type of network that needs to be more resilient than just crash fault tolerance. So we're talking about networks like Bitcoin network, where um, there is um, there is a high chance that um, not just the fact that some nodes might be crashing, but some other nodes might be trying to hack the system or trying to subvert the system. So we are operating in a very adversarial environment when it comes to Bitcoins. And if you want to formally define that adversarial environment, it is very similar to an environment where there is a group of people and they decide to operate in a certain way, but a very small subsection of that group of people, because of their vested interest, operate in a different way for a very small other honest section of that group, and operate in a completely opposite way to another set of people in that group. So they're basically dishonest. And the reason why they might be dishonest is because they they either are in collusion with someone who wants to bring the network down, or the very fact that the network operates at in a very confused status gains is helps them gain something. But at the same time, it is possible that the network can be built in a way that it survives such a situation also. So this is a situation um, much more serious than just crash fault. It is a situation where you have to ensure that the network continues to function without trusting a certain subsection of the network. And in such a situation, um, what has to happen is that you introduce a consensus that cannot be overridden or hacked or subverted in any way. And proof of work is that consensus mechanism. The very fact that to validate your block, you have to go through proof of work, which requires um, a level of computing that you cannot shortcut, ensures that every subsection of the network that's trying to subvert it will actually find it very, very difficult, in fact, impractical to subvert it. And this kind of tolerance um, of the network is called Byzantine fault tolerance. And Bitcoin, with its proof of work proposition, solves the problem of introduction of Byzantine fault tolerance only practically. So when it comes to, let's say, someone deciding to build a network that's tolerant in such a scenario, theoretically, it's not possible to do that. It is not possible to build a network that can be fault tolerant to such kind of faults. But it is possible to to practically solve it. So, and how Bitcoin practically solves it is by making the process of subverting the network so difficult that if someone were to decide to subvert the network, the gain that they will have or what they'll get out of subverting the network is so negligible compared to the resources that they'll have to mobilize, that no one actually finds it, their worth to actually try to hack the system. It's very similar to someone planning to steal from a bank. Now the bank um, locker is so strong that you'll have to probably buy a drill system that is $1 billion. But what's inside the locker is just maybe $100,000. Then it makes no sense to steal from the bank. That is exactly, I mean, that's a good analogy from how when it comes to Bitcoins. What you'll have to do to replace the entire Bitcoin blockchain is to calculate hashes of the entire blockchain from when it was started to right now. And you have to do it in 10 minutes time. So all over the world, people take 10 minutes to calculate one block hash after putting in an amazing hardware in place. If you're trying to break that, what you'll have to do is you'll have to calculate that same hash for every block before the next block is committed. So the amount of effort or resources that need to be put in place are astronomical. So that was like the explanation, high level explanation of consensus. We will again take a look at the code that I ran in the last session to explain it a bit better.
આમાં ફાઇલ બે ફાઇલ બનાવી હતી કેન્સલ થઈ ગયેલી હોય ને એન્ટ્રી બાકી હોય પછી
Sorry for the interrupt, sir.
Is there a question? Okay, so coming back to our private and public blockchain discussion, we've established that private blockchains can be crash fault tolerant. It's okay for them to be crash fault tolerant, but public blockchains have to be Byzantine fault tolerant. That's a simple explanation of a very basic difference between private and public blockchains. Now, we've also seen that Bitcoin, with its limitation of only being a Bitcoin transfer system or cash transfer system, we have to think of another blockchain that can support this smart contract thing that we have been proposing. So there are two important frameworks that we have to talk about when it comes to private and public blockchains. The framework that is of interest to us from public blockchain standpoint is the Ethereum blockchain. So Ethereum is the most popular public blockchain that supports smart contracts. Right now, any smart contract or any decentralized application that is built is 90% of the times targeted towards Ethereum. And when we want to compare Ethereum and Bitcoin, there are a lot of similarities. Ethereum also has a proof of work concept, although their proof of work is slightly different than the simplistic zero-based hash difficulty level proof of work. But it is proof of work, which means it is computation intensive. It takes some time for Ethereum proof of work, just like Bitcoin proof of work also. And just like Bitcoin blockchain, Ethereum blockchain also has Ether, like a cryptocurrency like Ethers, just like Bitcoin. And just like Bitcoin, it has a community that runs um, various nodes that operate the blockchain by confirming blocks and submitting those blocks and earning block rewards. So the difference comes when it comes to smart contracts. Ethereum blockchain allows for deployment of smart contracts. Bitcoin blockchain does not. And in Ethereum blockchain, we um, build smart contracts using a language called Solidity, which we will take a look at. And the process of deploying smart contracts in Ethereum is that you write your contract in Solidity, you compile it, and that compiled code is put on the blockchain or stored on the blockchain in the exact same way that we had talked about earlier. Now, we had talked about digital signatures as a way to verify identity in public blockchains. Both Bitcoin and Ethereum have the same logic. They introduce the concept of a wallet in which you store your private key, and then there is an address or an account, which is the public component of that private key that represents your identity. So these are some high-level features of the Ethereum blockchain. One thing that needs to be understood is that Ethereum started in the year 2014 as the smart contract enabled counterpart to Bitcoins. And some of the ideas around mining and transaction fees, they are very similar to the Bitcoin blockchain. And when it comes to some of the tools, they are also very similar to Bitcoin. So when I want to set up an Ethereum blockchain, what I am supposed to do is I am supposed to download a client node software and then run it on my system and then synchronize with the entire network, basically download the blockchain and then start accepting transactions, submitting blocks, whatever that I want to do. Exactly like how it works in the Bitcoin blockchain. The cryptocurrency that is supported in the Ethereum world is called Ether, sometimes also referred to as Ethereum. Apart from being the cryptocurrency that has value and can be traded and owned and sent and received, Ether is also an accounting mechanism for Ethereum. Now, what does that mean? What it means is that so first thing that we have to understand is that both Bitcoin and Ethereum, whenever I execute a transaction on these blockchains, I have to pay a small amount of transaction fees. It is paid in the same native cryptocurrency, that is in Bitcoin blockchain, it'll be Bitcoins. In Ethereum blockchains, it is Ether. And this small transaction fee, it goes towards the miner who's accepting my transaction and verifying it. It is not the block rewards. It is just meant for miners who are in the process of accepting my transactions and um, also in the process of sparing some computing power to verify that transaction. By verification, what they need to do is they need to check whether I have enough balance to execute the transaction, whether the um, address after decoding the digital signature is mine or not, and the transaction is formatted in the right way or not. So that transaction verification requires the miner to be compensated, and that transaction fees goes towards that. In Bitcoins or the Bitcoin world, that transaction fee is almost always the same for um, any transaction. That is not true for Ethereum. In Ethereum, that transaction fee can change if you're trying to execute a contract. So that leads me to explain two kinds of transactions. In Ethereum, you could either be executing a transaction which is a plain transfer transaction, which just transfers 10 Ether from my account to your account. So transaction fee for that transaction is almost always the same. But there could be a transaction that could be executing a smart contract. And that transaction is going to be very complicated. It will have parameters, it will have events, it will have a way in which you might be receiving a response for that function call on that contract. So that complexity makes it difficult for a miner to, not really difficult, but complicated for a miner to verify that transaction. So the transaction fee has to be slightly more. They need to be compensated more. That means that I should be paying more ethers for that transaction. And the amount of extra ethers that I pay is proportional to the complexity of the transaction. And there is a concept called gas that quantifies that complexity. Now, if that transaction is executing, let's say, a loop, if I've written a loop in my smart contract, then verifying that contract, that transaction is going to be very difficult. And the units of complexity are going to be more. So let's say a simple transaction, if that is 10 units, then a loop transaction might be 100 units. This unit is called gas. And there is a price for 1 unit of gas, price in ethers, which makes it easy for me to say that, hey, for this transaction, the complexity is 100 gas and 1 unit of gas costs, let's say 1 ether, just for example, then I have to pay 100 ethers. So Ethereum forms that accounting mechanism for executing contract transactions and regular transactions on Ethereum. Now we come to the accounts. So here we can jump to like a tool that is used very frequently in the world of Ethereum. It is called Etherscan. So let me know if you can see my browser screen. Okay, there is a question. So what I would request you to do is every time you ask a question, just unmute yourself and tell me, because I'm not following the chat. It's not on my front window. So the question is the blockchain totally different from traditional banking ledger? It's not totally different in the sense that a blockchain is also chronological entry of money transfer transactions. So that's where the similarity is. But a traditional banking ledger is very complicated. Although we have been talking about it in very simple terms, but that's not how simple it is. That ledger is keeping track of your accounts. It's keeping track of your balances. It's keeping track of your entries that you make in different durations. So there would be a ledger that would keep track of your balance for a financial year. There will be a day ledger that keeps track of your entries during the day. And then it has to link back to a lot of other data stores or data schemas, like along with your account, there'll be your personal details. Along with the transaction entry, there'll be a link to a general ledger entry, which is basically the operating account for the bank. So in spirit, it is the same. But when it comes to complexity, blockchain ledgers are very simplistic. Banking ledgers are highly complex. Hope that answers your question. So I was talking about Etherscan. Etherscan is a browser-based tool. Not really a tool, it's a service that you can access from this website that gives you a view of the transactions and blocks that are being committed to the Ethereum blockchain. So on the right side, you've got these latest transactions. The last one came 36 seconds ago. And then you've got the blocks. So this block, which is at height 12142, blah, blah, this came 1 minute ago. So this is real-time data. If you refresh it, you'll see more data here. So this block, this transaction which came a minute ago was from this address to this address. And if you want to look at this transaction in detail, you can see a lot of other things like the timestamp, the block height. This is the number of blocks that the Ethereum blockchain has. Then you can see the value, how much ethers were being transferred. Its dollar value, multiplying it with its dollar amount. Then the transaction fees. This is the fees that I was talking about earlier. Now in this view, you'll see the address. This is the address that represents a portion of your public key. There is a from address and a to address. So this is the from address, as in the address from which the transaction was initiated. And this is the true address, which is the address to which either money is being sent or the address on which a contract is deployed. If this was a contract, this would have said that this is a contract. So it's like a normal address to which money is being sent. You can see some more data if you click on the more data link, which will tell you more details about this transaction. And here you see the gas price and gas limit. So the idea of gas, which basically is how I explained it, is keeping track of how complicated it is to execute this transaction. So 1 unit of gas costs this much ethers. So small amount of ethers, you see the decimal. And the transaction used this much gas. So you can multiply this and you'll get this transaction fees. Now, had this been a transaction to a contract, let's look at a transaction that is a contract transaction. This is not. So this is a contract transaction. You can just view the title, the blurb there, tooltip, that it is a contract execution completed, means it's a contract transaction. In the contract transaction, okay, it's not a contract. Wait. Yeah, this one. This will be a little more detailed, where it will say, so I don't know if you guys are familiar with NFTs. This is a transfer NFT or sale NFT transaction, where a transfer of this NFT was made from this address to this address. The token ID for this NFT was this. Now, this is a transaction that consumed a lot of gas. You see that the amount of gas is different. So the transaction fee is also different. And the structure of this transaction was very complicated. Look at the data that was a part of this transaction. It was executing this function on the contract that it was sent to. And the amount of data that it had was this much. So Etherscan is the tool that lets you look at the transactions. And the accounts, which is basically last 20 bytes of your public key, is the account that initiates and receives transactions. So this is the account address. If you want to look at the transactions which we just did, the important part to understand about transactions is that they have like a key that differentiates them from other transactions. It's called the transaction hash. You'll find it here. This hash is going to be unique for all the transactions on the blockchain. And there are, I think, millions of transactions for Ethereum today. So each transaction will have a unique reference ID or hash. And you can search for a transaction by looking at it this way. You can search for it here. Then once you've kind of got these basic principles of ethers, gas, account, and transactions, now you can talk about the Ethereum smart contracts. So we will demonstrate the execution of a contract in our last session, but the contract looks something like, let me see, something like this. So this is the Solidity code that represents the very basic template structure of a contract. When we will be writing our contract, we will be writing it this way. Our logic would be inside this curly braces that basically represent the name of the contract and its logic that you're going to implement. So this is a very high level, obviously, extremely high level overview of Ethereum. What we will be doing with Ethereum in the coming sessions is, one, we will try to deploy our own Ethereum blockchain. Two, we will execute some smart contracts on the testnet. Three, we will try to access those smart contracts. We will deploy them and then we will access them in our own client application. Before we wrap up the first part of this session in about 7 minutes, I quickly also want to talk about Hyperledger. So Hyperledger is the public flavor of, the private flavor of blockchain technology. And Hyperledger is the most popular, just like Ethereum is the leader when it comes to smart contract enabled blockchains. Hyperledger is the leader for private blockchains. Hyperledger, in fact, is a group of solutions. We call it solution suite. So when you go to the Hyperledger website, you will see a diagram like this. So we will be talking about Hyperledger Fabric, but there are various other distributed ledger solutions, utility libraries, tools, and some domain-specific projects in the Hyperledger umbrella of projects. So when we talk about what is Hyperledger, the one thing that you'll read very frequently is that it's modular. It is made of modules. And when we talk about the modular nature, one thing that we can very quickly contrast from the Ethereum blockchain is that to build and run the Ethereum blockchain, you just need one client software. Usually there are various Ethereum client node software out there, but you need just one of them. And inside it, there is all the logic of synchronizing with blockchains, submitting transactions, verifying them, mining, all of it is there inside that software. When it comes to Hyperledger, what the creators have realized is that the verification logic should be allowed to be customized. So today, if I'm verifying a transaction in a certain way, maybe tomorrow I want to, or maybe in a different scenario, I want to verify it in a different way. So there should be a separate module that just does the verification. Smart contracts, which are called chain code in Hyperledger. What we are saying is that that chain code execution should be done in a different module altogether. It should not be clubbed in, a single monolithic module. Similarly, enforcement of policies. When it comes to Hyperledger, there are we talked about the access control and everything. So that enforcement should be in a different module, and all of them should be allowed to plug and play together and work. So Hyperledger is a very modular solution, especially Hyperledger Fabric. So Hyperledger Fabric is one of the solutions that Hyperledger provides, and our focus is going to be Fabric. And all of the principles or philosophies that go behind each solution in Hyperledger are also represented in Hyperledger Fabric. So there are different modules, as I said. The first one, an important one, is the ordering service. When we submit a transaction. Sorry, is there a question?
No, sir.
Okay. So we have these various modules that have their role and responsibility. We've got the ordering service that establishes a sequence of transactions as they are received by Hyperledger network. We've got membership service, which verifies that a certain entity that is sending a transaction is the member, and they validate their certificates and everything. Peer-to-peer network, which is basically introducing the ability to broadcast a transaction, synchronize the blockchain ledger state. All of that is another module. Smart contracts, a completely different module. So we have these various modules that operate together in a certain way to provide the capability that is Hyperledger. So what Hyperledger proposes to do is that it defines the blockchain as a business network, and it rolls that business network idea to a certain domain. So in its typical installation or its typical instance, Hyperledger builds, let's say, a network for supply chains, which is a domain or a vertical, or trade finance, which is a vertical, or healthcare, which is a vertical. So when we will build Hyperledger network, a business network in Hyperledger, we have to at the outset know what domain are we building it for. And once identified, then we will construct the business network in a way in which every participant of that domain is a potential node or a potential peer. In Hyperledger, nodes are called peers. So they are a potential peer in the business network. So if you talk about, let's say, building a business network for shipping, then all big shipping companies should be considered to be a part of that network. Along with shipping companies, there might be more entity types like distribution companies, customs authorities, port authorities. They should all be identified as potential participants in the network. Now, with that, we will take a short break of about half an hour, 40 minutes, and reconvene. We are doing good time. We've talked about public and private blockchains and talked a little more detailed about how Hyperledger, how Ethereum operates. We will try to talk about Hyperledger in similar detail in our next session. And then we'll talk about some more blockchain types like IOTA, BigChain, BigChainDB, and EOS. These are some interesting platforms also, but our focus will continue to be Hyperledger and Ethereum. So with that, let's take a quick break. We'll reconvene in 35-40 minutes. Thank you.
Thank you, sir. So we are wrapping our session for the lunch. We are meeting at 1:30 p.m.